Hello everyone. Today we are going to wrap up section 6.3, which started with finding the trig functions at any angle. The second day we developed the unit circle, and today we're going to talk about the trig identities. Now this is meant to be an introduction. Trig identities are something that you will do much more with in pre-calc next year, but I always feel like it's good to have a little foundation, and I think it'll make next year's process with these a bit easier. Trig identities are used a lot of times in order to simplify expressions or equations to make it easier to solve or to deal with. But first, what I thought I would do is talk about what is an identity. Now, I'm doing this in section 6.3, but it actually is from our book in section 6.2. If you're interested in reading to make sure you kind of see how these work, if you're on page 437 in our book in section 6.2, that's where this text describes trig identities. I like doing it after the unit circle because we're going to use that to help derive one of the identities here in a little bit. So first of all, what is an identity in mathematics? An identity is something that's always true. So for instance, we have one of the first identities you learn in math is the commutative property, the idea that A plus B equals B plus A, right? We want something, we talk about an identity, something that is always true. And so first example you have is the commutative property of addition. We have the additive identity, that anytime I add 0, we get what we start with. The multiplicative identity would be if I multiply by 1, we get what we started with. So it's something that is always true. And so when we talk about the trig identities, there are 3 types we're going to talk about this year. The first are the reciprocal identities. So we've learned these as we've been developing our right triangle trig ratios, that cosecant is the reciprocal of sine, so 1 over sine. Secant is the reciprocal of cosine, 1 over cosine, and cotangent is the reciprocal of tangent. Now I could rewrite each of these so that I could have sine equals 1 over cosecant, cosine equals 1 over secant, and tangent equals 1 over cotangent, but I think more often you're going to be rewriting things in terms of sines, cosines, and tangents. The second type of identities that we have already talked about when we talked about the unit circle was we talked about how tangent of theta is y over x, and on the unit circle that was sine of theta over cosine. So we can always write tangent as sine over cosine, and cotangent is cosine over sine. Now, let's see how these problems are used. So example 1, it says use the trig identities to show that the left side of each equation equals the right side. So what the trig identities are used for is to take something that looks very complicated and simplify it, usually to a single trig ratio. So for instance, in A, I want to show that cosine of x times tangent of x times cosecant of x equals 1. So the first thing you usually do with these identities is, if nothing else, start with just writing things in terms of sines and cosines. So cosine, I'm not really going to do anything with this, but I know tangent is sine of x over cosine of x, and cosecant is 1 over sine of x. And so now cosine divided by cosine is 1, sine divided by sine is 1. We have shown that 1 is equal to 1, that this is an identity that is true. B, sine of x times secant of x equals tangent of x. So I'll start with nothing really I'm going to do with, so I could do this a couple of ways. I'm going to show one here. Sine of x is just as it is. Secant is 1 over cosine. So when I multiply, I get sine of x over cosine of x, which is tangent of x. So we have shown that the left side simplifies to be tangent. And then with the third example, let's show that cotangent divided by cosecant of theta equals cosine of theta. So cotangent of theta is cosine of theta over sine of theta, using my reciprocal identity. Cosecant is 1 over sine of theta. Now, a lot of times when you're doing these identities, you're going to deal with fraction work. So in this case, I have a fraction divided by a fraction. So to simplify, I'm going to take the numerator times the reciprocal of the denominator. So here the signs divide out, and I'm left with cosine of theta, which is what I wanted to show that it equal. So in each of these cases, we have shown that the left hand of the equation is equal to the right hand using identities. The next type of identity, the Pythagorean identities, are the ones that you're probably going to use more than any other in the future. And this is why I wait to do these. When we think about Pythagorean identities, it's going to have something to do with the Pythagorean theorem. So the main Pythagorean identity is, think of the unit circle. And last lesson, we talked about how any point on the unit circle, the x-coordinate, if this is theta, is cosine of theta of this point, and the y-coordinate is sine of theta. So that means I have a right triangle here where the x side is cosine, the y is sine, and the hypotenuse is 1. So if I use Pythagorean theorem, I have that sine squared theta plus cosine squared theta is equal to 1. And that is the first and the main Pythagorean identity. Sine squared, just here, plus cosine squared is equal to 1 squared, just plugging into Pythagorean theorem. Now, there are two other Pythagorean identities, but you don't have to memorize them. Just start with this first piece. We know that this is true. Sine squared plus cosine squared theta equals 1. Now, to derive the second Pythagorean identity, I'm going to divide everything by sine squared. If I divide everything in an equation by the same thing, it's still equal. And now I have sine squared divided by sine squared is 1. Cosine squared divided by sine squared, well, cosine theta divided by sine theta is cotangent. So cosine squared divided by sine squared is cotangent squared theta. And 1 over sine is normally cosecant, but it's squared. So we have cosecant squared theta. So here's the second Pythagorean identity. And now to get the third Pythagorean identity, I start with the original. And now I'm going to divide everything by cosine squared. And if I do that, sine squared over cosine squared would be tangent squared theta. Cosine over cosine is 1. 1 over cosine is secant squared theta. And there is my third identity. So the Pythagorean identities are based on the Pythagorean theorem. And we start with the sine squared plus cosine squared is 1. If I divide each of these three terms by sine squared, it simplifies to 1 plus cotangent squared equals cosecant squared. And if I started with the original and divided everything by cosine squared, we get tangent squared plus 1 is secant squared. Those are the three Pythagorean identities. So now let's do a couple of problems where we're going to use identities to show again that both sides of the equations are true, that secant x minus sine of x times tangent of x is equal to cosine, and that secant of x plus 1 times secant of x minus 1 is equal to tangent of x. And these can use any of the identities that we've talked about so far. So if I take a look at the first one, secant x. So again, the first thing I would do with most of these problems is write it in terms of sine and cosine. So I have what you see here. I have 1 over cosine of x for secant minus sine of x times sine over cosine. Well, now, this is really 1 minus cosine of x minus sine squared of x, right? Sine times sine over cosine of x. Now I'm going to subtract fractions. Well, the denominators are the same, so I can go ahead and rewrite the numerators 1 minus sine squared over cosine of x. Now, notice how I have a sine squared here. Well, if I want to have something that's related here, we know that there's a Pythagorean identity for 1, right? We have that involves sine. We have that sine squared x plus cosine squared x is equal to 1. So I am just going to substitute sine squared plus cosine squared for the 1. So I still have the minus sine squared x over cosine of x. Now, look what happens. Sine squared minus sine squared, it goes away. I'm left with cosine squared divided by cosine of x. So it's kind of like taking x squared over x, which just leaves me with cosine of x, which is what this problem first wanted me to show. Now, you might get in the habit here of eventually seeing that this is just a manipulation of the original Pythagorean identity, right? If I start with sine squared x plus cosine squared x equals 1, then if I just move this over, then I can pretty easily see that cosine squared of x equals 1 minus sine squared. And so I can just do that substitution straight from that step without having that intermediate step that you see there. But I thought as we begin, that may help you see that one. All right, B. Let's try this one. So we want to show that the product of secant of x plus 1 times secant of x minus 1 is equal to tangent of x. So we're going to go ahead and multiply this out. So I have secant times secant, which is secant squared of x, minus secant of x plus secant of x minus 1. So I get secant squared of x minus 1. Now, again, we have a Pythagorean identity that deals with secant squared. And it's that secant squared is equal to, if I do my substitution for secant squared, I can plug in tangent squared of x plus 1. And then I have the minus 1 here. And so I get tangent squared of x on this side, which don't look right now. That's what I was trying to show. Sorry about that. Is that the left side actually ends up equaling tangent squared of x with that Pythagorean identity. And we kind of could use the same idea as I talked about previously, is that if we know that tangent squared x plus 1 equals secant squared x, then I can easily move that over and see that tangent squared x is equal to secant squared x minus 1. So I can jump from this step to that step without showing that little intermediate step. But as you're getting used to the identities, it doesn't hurt to show the extra step. And I'm sorry about the original problem for getting that square there. I really did want to show that. So, trig identities. There are many, many more identities that you will learn in future classes, but these are the main ones that we are going to use. And they're used to simplify trig expressions so that when we solve trig equations, they're easier to solve. When we graph things, things are easier to graph. And so let me just review real quick. We have the reciprocal identities, which cosecant's 1 over sine, secant's 1 over cosine, cotangent 1 over tangent. Not really new information. We knew this. Quotient identities, again, something we knew. Tangent is sine over cosine. Cotangent is cosine over sine. The new information and the new identity, beyond just how to simplify with these, is your Pythagorean identities. That sine squared theta plus cosine squared theta is 1. That 1 plus cotangent squared equals cosecant squared. And that tangent squared plus 1 equals secant squared. So, try the homework with this. And if you have questions, pretty soon we will have another Google Meet. I'm happy to answer things and help get things squared away. Pretty soon we'll be getting ready for our first assessment for e-learning. I hope you all are doing well. I miss being with you guys in class, and I hope to see you soon. Take care. Bye.